Hey friends, how's it going? Back again with a new video for you. This time around I'm going to try and do something a little bit different than what I've done in the past. Most of my videos have always been things like showcasing programs and whatnot. And this one's going to be kind of showcasing it, but I also wanted to take some time to teach about something that I was recently having a hard time figuring out. Let me just show you what I got going on here. So as the title suggests, it's about using a TCP server in C Sharp. And I actually found this video. I'll post a link to it in the description down below. This is from, I believe it's FoxLearn. Yeah, and it's basically how to use the library Super Simple TCP for C Sharp in Visual Studio. And it was a really cool video, really super informative. If you haven't seen the video and you're looking to build a TCP server in C Sharp, that's really useful for a variety of different things, then I would definitely check out Fox Learn's video and their channel too. They're really awesome. I don't get any special credit for plugging them or anything like that. I want to give them a shout out because they really helped me with this project that I'm working on for work. But anyways, after watching this video, I started reading through the comments because I was having trouble with something else, and I came across this comment here from, there we go, user Natural Wonders, that said, how can I get the client computer name and put it into the list box together with the IP import? And let me show you what I mean, what it does, and then we'll talk about what Natural Wonders wanted. So here is the actual program. I've already followed the tutorial and built the program. I made a couple small changes. I'll talk about those in a second, but this is essentially what it does when it runs. So it builds a super simple TCP server, which populates, first of all, with my IP address. So I'm going to copy that real quick. We start the server here. And then over here, I'm going to put that same server IP address. I'm basically just serving to myself on my local machine. And when I connect, you can see that I'm connected here. Now, here is what it essentially does. It's just a simple messaging app, but it's really cool. When you click on the IP address in the list box and you send a message, it sends it to that particular client. So you can see it show up right there. And then that client can send a message back to the server, and you can see it show up there, which I thought was a really cool thing. And I used it as the kind of foundation for another program that I'm building for work. But what User Natural Wonders had mentioned was, how do I get the client name in this box instead of the IP address? And I can understand where they're coming from, because if you've got a lot of different clients connected to a server, you may not know as a user which IP address goes to which computer. And so it can be super helpful if each computer has its own name listed here in the list that you can select them individually. Again, for my project, I would have a variety of computers that would populate here, each one of their names showing up, and then I can select that name and send that computer, that specific computer, a message without having to know which IP address is which. So I want you to make note of what I'm seeing here. This, of course, is the IP address, but you'll also notice this number here at the end, the 51232. This whole thing right here is the socket that we're going to need to know for this next part that we're going to be developing. So without any further ado, let me go ahead and stop the program, and we'll take a look at what we've got going on here. First of all, it uses the library Super Simple TCP, which I can't remember who it's by, but if you go into your solution and, or sorry, the project, and you go to manage NuGet packages, you should be able to real quick search for it. Yeah, and this is all in the video from FoxLearn also. There it is, Super Simple TCP by Joel Christner. So if you are going to use that, Joel Christner actually put on his GitHub a lot of really good information in the README about how to use this. So check that out. And it's a really good introduction way to get into TCP servers and whatnot. But anyways, so it uses that. And then here in the server, what I did was I changed some things around from the FoxLearn video. Instead of starting the server right here when the right here where the server, it says server load in this message, or in this method, instead of starting the server here, what I did was I moved all of the starting server and observable subscriptions and everything down here to the click button start. And the reason I did that was so that when it does load the form, the user does have the option to change the IP address if they wanted to. So again, when I start up this program here, you can see that I've got the option to select and change the IP address if I wanted to whatever, whoops, those are O's. If I wanted to change it to something like, you know, the local host or whatever, something along those lines, I can. But it's, I thought that was like a better way to just kind of do the whole thing. But other than that, oh, and I added one extra method down here, and this one's called get local IP address. And what this does is it gets the IP address of your current machine. So in the Fox Learn video, what they have, the developer did was have that list box populate with the 127.0.1.0 or whatever localhost IP address is for his machine. Um, I wanted it to populate with that particular machine's uh, IP address on the network. So again, when I start this up, you can see that instead of the 127.0.0.1, it populates with my actual network IP address here on my home network where I'm recording this. And if I were to take this into, say, work or another area like a coffee shop or something and get on, this IP address would be different because I'd be served a dynamic IP address, and it would populate that instead when I start this program. And I wanted that to be the case because, again, for the project that I'm developing, it needs to have the IP address automatically put in here as opposed to because it can't just be serving on the local host. It has to be serving on an actual IP address on the network so that other computers can see it. And then it adds this right here, the port 9001 onto it. So, and I'll show you what that does essentially right now. So again, going back to here, um, here at the top where it says server load. The first thing it does is it says text ip.text. That's in the form. So right here in this form right there, this is like the standard right there, the 127.0.0.1 9000. That's just what the original text is, but this is the text box or the text IP box. And so I set that to get the local IP address. So that's this method down here, right there. So it gets this local IP address, returns it as a string, right back up here to the server load, and then it adds the 9001 to it automatically. So regardless of, depending on where I end up going, it will always load the current local IP address for me. And then in the client program, I don't think I really changed anything except for, again, I moved all of the client stuff down to the button connect, the connect button here. So this button right there. So again, it gives the user the opportunity to change this IP address if they wanted to. So as you saw when I start up my program, it populates with the 127, but I copy over my other IP address or my actual IP address into this box so that I can actually connect to the server. And then it does all the connecting. And then, of course, it's got the try-catch block, but I think FoxLearn added that in there as well. And then that's it. That's basically it. So with that, what I want to do is actually add one extra feature into this setup here, the server and client setup, so that when I start the program and connect a client, that instead of just getting an IP address from that client, I actually end up getting a name for that computer so that it's much easier for me to uh, communicate back and forth between the two. So that's what we're going to do right now. Okay, so the first thing that I actually want to do here is I want to figure out how exactly these the server and client, these programs are going to talk to one another. And in my opinion, the best way to do that is to serve it with header files. And we'll get to that in just a second and how those look. But I also need to make sure that the server can store a list of all of the clients that are connected to it so that it can, when it receives a message from a client, it can basically backcheck the client's IP address that it's receiving the message from with a name and then show the name instead of the IP address. And I'll show you what I mean here as well in that. So the first thing I want to do is underneath this private super simple TCP server, I want to make another field here, and this is going to be a dictionary. And we're going to make it house a string, and we're just going to call it table. That's all. And then when the server loads, just after I get the IP address, I'm also going to make the table. So I'm going to say table equals new, and that's going to be dictionary string. All right, so now that I've got that being created, what we're going to look at now is connections. So when a client gets connected, what I want to do is I want to ask it for its name, like its computer name. And so instead of listing the IP address, which it's doing right here, I'm going to instead ask it for I'm going to request for its computer name, and that'll be something that the client will have to be able to do. It'll have to be able to get its own computer name and send it back to me as well. So we're going to get to the client in just a second, but for right now, I'm going to go ahead and comment this line out because I don't want to list the name of the IP, or I don't want to list the IP address. Instead, I'm going to say server.send, and I'm going to basically send it a message, and I'm going to send it to the IP port that just came in. I'm going to send it a message that says request name with a plus, and that's going to be the header file, or I should say just the header of the string. And I'll show you what I mean in just a second with that as well. And then plus the IP port that I am sending to. And so let me explain what's going on here. So essentially, when I send a message with super simple TCP, it sends it as a string. I'm sending this data as a string. And so what that string should look like in this case is I want to have a header file. So that's going to look like header file. And then I want to separate that header, and I shouldn't say header file because it's one long string. So what I want to do is I want to make sure that the string is built in such a way that it can be separated easily by the client. So I'm going to start with what I'm going to call a header, and then I'm going to have a splitter object or a splitter character. So in this case, I use plus, and then from there, it will be the message that I'm sending. So essentially what happens is when I send this from the server, it's going to have a header, and that header is going to be request name. It's going to have this splitter character that's going to be plus right there. And then I've got the message. And in this case, the message is just simply going to be the IP port that I received initially from that client when it connects. And the reason I want to send that is because as you notice when the program starts up, you get an IP address. So it's something like 192.168.3, or sorry, .0.140, something like that. But then it has a colon, and then it's given a randomly assigned port, and that port is usually something like 87456, or get that out of the way, or 45667, or something along those lines. And this right here makes the entire socket that I'm connecting to. The thing is, though, this number is randomly generated when the client connects. So even though I start off by saying 9001, that's the port that it's sending out of, but then I'm receiving it back from some random port that's usually 5 digits. I need to know what that port is, though, so I can connect properly. If I just simply say the 192.168.0.140 and then 9001, it's not going to connect properly. It's not going to actually be able to find that particular client. So what I need to do is I need to make sure that I'm actually getting the IP ports, or the IP address and the ports, so the entire socket that I'm receiving that message from. All right, so that's important right there. So with that, I'm good on that particular part right there. So I'm going to move down to, actually, let me see what's going on here. I've got this weird message happening here, and I don't know why it's being so. We won't just get out of the way. There we go. Just going to do that. Yep, there we go. Perfect. All right. Just needed to delete and undelete it, I guess. Whatever. So anyways, so now down here in client disconnected, we'll come back to that in just a second. I'm not too worried about that. What is going to happen, though, is the client is going to send back some information to me once it gets this message, the server.send, with the request name plus. But my client needs to make sure that it understands. I need to make sure that the client understands what this message means. So I'm actually going to jump over to the client side right now. I'm going to be kind of going back and forth between these two files. So just to make sure like you've got them both open as well if you're following along, I'm going to go to the client side. And again, with the client, I need to, again, make sure that it understands what headers are. So I'm going to, let's see, I'm going to go to here, data received. Actually, I'm going to do something else first. So with the client, it needs to know what its name is in order to send that name back to the server that's requesting it. So I need to actually add a few extra fields in here. Oops, so I'm going to do that up here just before I initialize the components. So I'm going to say, let's see. All right, I'll do it right here. I don't know why this is down here. I'm going to move that up actually. All right, so after I've made the client, I'm going to say private string, and I'm going to call this local computer name. Real obvious right there. And then I think that's good. That's all I need. And so now in order to get that local computer name, I need to have a method that will allow me to grab that. So down here at the bottom, I'm going to add an extra method. I'm going to say this one's going to be a public string, and it's just going to be called get local computer name. And it is not going to have any arguments. And then what we'll do is we'll say, let's see, we're going to say var name equals, we're going to say dns.get host name. There we go. And then we're just going to return dns.get host name. And that's it. Actually, I don't even know why I did that extra step right there. I guess I could just say return name. That should be fine as well, honestly. And really, I mean, if you're doing good coding practice, we can just go ahead and actually put this right there. Get rid of the whole need for the variable in its entirety. So I don't even know why I did that. It's just out of habit, I guess. So there we go. So get local computer name. All right. So now that I've got a way to get the local computer name, when I load the form, the first thing that I want to do is, let's see, I'm going to say local computer name, and we're going to say equals get local computer name. There we go. So now the local computer name will be stored here in that variable. All right, so now the client knows what its name is. All right, now if you remember correctly, at the server point, when I connect the client to the server, I invoke this first. I basically send it a message immediately. So as soon as the client connects, then I'm going to say, hey, it's connected. And then the server is going to immediately send it a message that has request name with a plus as its header. And the message will be the IP port that the server received the client's connection from, or the connection came from. So I need to have the client have a way to understand what this request name plus an IP port actually means. So I'm going to go back to the client, and whenever the client receives data, that happens right here in this data received, call it observable. So what I want to do is I want to kind of get rid of all of this original code, right? And instead I'm going to say, I'm going to actually take in the data initially and just immediately convert it into a message. So I'm going to say message received. And that's going to be, we're going to say equals the encoding and .utf8. And you may have noticed too, if you were following along with the Fox video, you may have seen that there was kind of an issue with converting the data into a string. I found that adding the toArray method or call on the end of this actually helps convert that right into a string for us. So if you're having an issue where that's an error, go ahead and add that .toArray thing. I'm not sure if that's an issue with like old C# because I'm using they were using like C#9. I'm using I think C#7 or something like that. So I'm not sure if that's the issue, but either way. So there we go. All right, so now that I'm getting the message and I'm converting it into a string, what I'm going to do is I'm going to look for if that message received contains the phrase request name. And you can add the plus here if you want. It doesn't really make too much of a difference here. I'm going to add it anyways. Now, if it does contain the request name, then I'm going to start putting things into variables here. So I'm going to say client with IP address, IP, oops, can't spell and talk at the same time. Oops, I'm going to say client IP address with port, because that's what I want. And I'm going to start building that string, and I'm going to call it. Now, again, what I need to do is make sure that the server also understands when it's getting information that's important from the client back to itself. So instead of a regular message, I'm going to add a header onto this one too, and it's going to be the same thing. I'm going to say name request, so that it knows that that's what it's getting from me is the name request. And there's my plus. That's going to be my splitter character. All right, and now here is the algorithm for how basically we're going to be be taking this request name plus with all the stuff. Because remember, what we've essentially just received from the server looks like this. It is request name and then a plus, and it should be something like 192.168.0.140, and then a colon, and then something like 56789. That's what it's getting from the server right now. So I've discovered in this, or I should say the client has discovered that, okay, the message received contains request name with a plus. So there you go. So that means it's going to have an IP address and a port in there. So I need to make sure I do something with that. So I'm going to start by creating the client IP address with port. That's going to be name request with a plus. Underneath that, I'm going to make a string array, and we're going to call that message split. And that's going to basically be the split of the message. And we're going to say message received dot split, and we're going to split it with this plus character right there. And then we're going to loop through that array. So we're going to say for each, and then that's going to be var, and we're just going to call them items. And each item in that string array message split is going to be, we're going to say in message split, each item in there, we're going to loop through one at a time. Now here's the thing, if the item, oops, I don't know what that is, if the item equals, there we go, if it equals the request name, then what I'm going to do is just continue. Like, I don't need to worry about that, right? So basically, this is me skipping the request name. But if it doesn't contain request name, because remember, right now at this point, this is what I've got: request name with a plus, and then I've got this IP address. So I have two items in this string called message split. The first item is request name. So if it equals request name when I go through the loop, I'm just going to skip it. But if I get to the next item, which is going to be this IP address right here, I want to do something with that. So I'm going to say client IP address with port, and I'm going to say plus equals the item. All right. So now right there, I've got a new string, and this new string says name request. There we go. And and then it has this IP address, the 192.168.0.140. And then it has that port, whatever that was, 56789. All right. So that's what my string looks like right now at that point. So now, after it's done with that, I'm going to add a couple more things onto it. So this is going to be, I'm going to say client IP address with port, and then I'm going to add a new splitter item to it. And I'll explain why I'm doing that in just a second. So I'm going to add a comma this time, right? And then I'm going to say one more thing. I'm going to add in the get local computer name, or in this case, I can just simply say local computer name. That works as well, right? And then I'm just going to say client dot send, and I'm going to send it that string, and that's it. So now what I've got here after I've done this is I have a string that looks like this. It says name request, and it has plus. Then it's got 192.168.0.140, and then it has 567.789, and then it has a comma, and then it has my computer name right there, whatever that computer name is. So this is what my string looks like. This is what the message is that I'm sending back to the server. All right. Now, if you're following along and you kind of have figured out what my pattern is going on here, you might figure out what I've got going on with this comma. So once the server receives this message, it's going to do essentially the same thing that I've done up here with the client. It's going to look for a message that contains, in this case, name request. When it finds that message that says name request, it's going to immediately remove the name request and the plus, or I should say it's going to split the string based on the plus into two parts. It's going to split it into name request, and then it's going to split it into this whole string right here, the IP address and the computer name. Then it's going to remove that name request, and I'm just going to be left with this. And then with this string here, I'm going to take it and split it by this new splitting item, this new character, the comma. And the reason I'm using a comma versus a plus is because if I were to use another plus, then when I do this string message split, it's going to split everything, and I'm going to be left with these two things in two different parts of the array, and that was just kind of complicated for me to separate out. I'm sure there's definitely a way, but this is the way that I came up with, so there it is. All right, and now one last thing that I want to do is, remember up here it says if the message received contains this, but I don't have anything for it to do if it doesn't contain that. So I'm going to say else, and this is going to be if the message is actually just a message. I'm just going to go ahead and add in the original whole thing. I'm going to say text.message. Actually, I'm going to do this. I'm going to say this dot invoke. You may have found that this is one of the things you have to do. Again, if you're following along the Fox Learn tutorial, this is because the program doesn't like to basically talk to the Windows form and vice versa. So in order to talk to the Windows form directly, the parts of it, and let it know that something has needs to change on it, you have to do the message invoker, and that's the reason for it. But I'm just going to go ahead and say list messages. Actually, I think it's called, what is it called? Message box? Sorry about this. I'm just so all over the place. Name this thing. I called it, oh, text info. That's weird. All right. So I'm just going to go ahead and say text info, and we'll say dot text, and we'll say plus equals, and then it will just be the dollar sign at, this was the right, it was the IP port. And I'm not going to worry about putting the IP or the actual computer name into the message box just yet. We can do that at a later date, so I'm not super concerned with it, but it's just going to be, we'll say the encoding. Actually, we can just say message. Let's see. Oh, and then we'll also do an environment dot new line. There we go, and that should be it. Okay. So far we haven't done a whole lot. We've just kind of set up the client for being able to send its name request back to the server. But I mean, that's kind of a big step. That's kind of an important part right there. And so with that, we don't really have to do anything else with the client. It's pretty much set up and ready to go. So I'm going to save that, and then we'll go back to the server, and then we're going to add in the method for it to be able to understand that it has not only requested a name, but that it's going to receive the name and then store it someplace, and then we'll access that name for the list to finish up. Okay, so let's kind of recap what we got going on here so far. So we've updated the client app to accept messages that have a special header line on there. And remember, the header, of course, is just simply the very beginning of a string that's being sent, because all I'm sending back and forth between these two programs is strings. So I want to make sure that I tag the string with what I'm going to call a header, and it's got a character, in this case the plus, that's going to separate the header from the rest of the message. And then when I send back a message with important information in it that I want to be separated out, I'm going to send the header separated by a plus. And then in the message, any important parts that I want to separate out later on, I'm going to separate those with a comma. So in this case, when the server has a client that gets connected to it, it's going to send a header with the message of just simply the IP port, the socket in this case, that the client is connected through. The client is going to receive that message, and it's going to take just the socket, and it's going to add it to a string that starts with header name request this time. And then at the end of this string, it's going to add in the name of the computer. So I'm going to be sending back to the server the name request header with the plus, the socket that it was connected to in the server, and then of course the name of the computer the client is. Now the reason I'm sending this to the client and then sending it back to the server is because the client actually doesn't know what its socket is on the server side. I did some experimentation with this, and that's why I came up with this algorithm, this system here, is that the client itself doesn't actually know what this number is here. It only can figure out this number when it's on it only knows its own IP address. It doesn't know which random socket or which random port it's being assigned when its message gets to the server. So in this case, the server does know this port number, so it's going to send all this information back. And in this next part, I'm going to explain why we want this. So back here in the server, what I've got going on here is I did the client connected. Now I'm going to skip the client disconnected for right now. I'm going to go to the data received. And now this data received is going to be very similar to the data received that the client deals with. So I'm just going to get rid of this. All right. And I'm going to do something very similar to what I just did with the client. So I'm going to say, let's see, we'll say string message received. And this is going to be equals, let's see, what did I do here? I said encoding dot UTF-8 dot get string. That's going to be e dot data, and then to, oh, all right, so now I've got a message received, and this is going to be the string that I just received the from the client, right? And I'll get to the other part in a little bit, but this will essentially be either a string that's actually a message or it will contain a header. And now here's the other thing too is you want to make sure that in this method here, you have to account for any type of header that exists. Otherwise, that header's not going to do anything. You can't just make up headers on the fly. So you have to be able to process the header. So for instance, if I'm at the client side and I send a message that doesn't have name request in it, it has some other header. If the server doesn't know what that header means, it's just going to process it as a regular method or as a regular message, and it's going to display it in the output. So you can essentially use this to uh, send all kinds of different commands. That's what my main project is about. But in this case, we're just going to be handling one specific string header or one specific header string. And in this case, it's going to be name request. So we'll say if message received dot contains, and it will be name request, and that basically means that the client has sent the response to the request for name message that the server sent. So in this response, I'm going to say, all right, string table equals encoding dot. Actually, no, I don't need to do all that. Let's get that. I'm going to say pair splitter. And this is just another way of doing the exact same thing that we did before. In this case, the splitter character is going to be the plus. There we go. Oopsies. Well, let me go back to this. Hold on. Duh. All right, there we go. All right, so this is going to be the character that I'm going to split it by, and then I'm going to say string, and this is going to be message split, and that's going to be equal to message received dot split splitter. And just because I want to, I'm going to add in some string split options, and I'm going to say remove empty entries. And this is just in case, for whatever reason, I get some entries that are completely blank. It's unlikely in this case because I know what kind of string I'm sending from the client, but I'm going to add that in there anyways, just for some, yeah, just because. And it's something that you can add in future things as well, in future methods. So now I'm going to loop through the message split. So I'm going to say var item in message split. And just like before, if the item dot equals, and in this case, name request, then I don't really need to do anything with it. I'm just going to go ahead and say continue, just like before. However, if it contains something else, then I'm going to now split it again. So here's what I've done so far. Up to this point, my string message received looks like this. It's name request and then plus, and then it's an IP address, 192.168.0.140. And of course, as I mentioned, this is just an arbitrary number and 5, 6, 7, 8, 9 is the port, and then it has a computer name, so computer name. So that's what the string looks like. So right here, now that I've split it, I have this string array called message split that contains two entries now. It contains an entry that is name request, and it contains an entry that is this whole rest of the string right here, including the computer name. All right. So here, as I'm going through the message split, I'm going to say if it equals name request, if the item equals name request, then I'm going to continue. I don't need to worry about it. However, if it contains something else, i.e., it contains the IP address and port, or the socket, and the computer name with a comma separating the two, now I want to do some stuff with that. And I'm going to do essentially the same thing that I did up here. I'm going to say char or char. I say char because it's like character, but shortened for character, but whatever. I'm going to just call this single entry cars. And this one is going to be a comma. There we go. And then I'm going to make a new string array. And the reason I'm making these all right now is because this is all locally scoped, so I can just get rid of them. I don't need to worry about them hanging around or anything like that. I'm going to call this one single entry because it's going to be an entry into our table. And I'm going to say this is going to be item dot split, and it's going to be split by the single entry car, or char. And my string split options in this case are just going to be none, because I don't have any that I need to worry about this time. I've already gotten rid of any empty entries, and at this point I shouldn't have any left over. Now that I have essentially split this up into two things, so right here, this single entry is in a string array, and it contains two items now. It should contain first this IP address and port, so this socket, and then two, it will contain computer name, There we go, computer name. So what I want to do now is enter that into the table. So I'm going to say table dot add, right? And I'm going to add in single entry, and it's going to be index 0, which will be the IP address. And then I'm going to add in single entry and index 1, which will be the computer name. And then for the very last thing, I'm going to say this dot invoke. There we go. And we're going to say method invoker. And that's going to be delegate. And what I want to do now is add this to the list of computers in that list portion on the right-hand side of the server window. So this will be, let's see, text IP, I believe is what I called it. And this will be items, info maybe, dot items. Wow, this is embarrassing. All right, let me go back here. This is where it is. This is what it is. Let's see, properties. What did I call it? List client IP. That's what it is. List client IP. Okay, so list client IP dot say items. There we go. And then we'll say add, and then we're going to add in single entry, and we want to add in the computer name, not the IP address, right? So what that should do is add in the name of the computer to that list, right? And now for the last little bit here, let's see where we're at. We don't have an else, so we're going to say else, and this is in the event that the message doesn't contain the header name request. Then we're just going to go ahead and this dot invoke method. Oh my gosh, I cannot type. Method invoker delegate, and this is going to just simply text message. I believe it's text message. No, it's text info, I think. Let me check before I get all weird about it. Hold on. I followed the tutorial exactly as it was. So I can't remember what we named the things. Yeah, text info. There we go. So I want to add in the message to the text info. So it's going to be textinfo.text. That's going to be plus equals. And then we're just going to go ahead and add in that string as it is. For right now, we're going to say, let's see, we'll say, Actually, we'll say e.ip port because a single entry doesn't exist yet, and we'll tackle that at a different time. And then we'll just do the encoding .utf8 .get string, and this will be e.data .to array. There we go. And environment .new line. There we go. Oh, that should be good. And then that needs a there. Okay. Got that going. Just make sure I put my colons, semicolons where they belong. Okay. So what I have here now is, just to recap what we've done so far. So the server, it gets this local IP address, and it also makes a table that contains a string key item and a string value. And well, it doesn't contain anything. It's just, that's what it's going to accept once we load the server. Then, once we start the server, it's going to load up all these things. It's going to subscribe to all these observables, and it's going to let me know that it's starting and give me the option to send stuff. Additionally, once I start a client, that client, once I load it up and once I load up the client, it's going to get its own computer name. And then when I select connect, it's going to connect to the server. When the server gets a connection, so back to the server now, when the server gets a connection, it's going to say which IP port just connected to it. Then it's going to immediately send a message back to that IP port with the header request name in a string and that IP port. All right. When the client receives that on this end, in the data received, it will find that the string, the message that it receives, contains request name. And it will immediately build a new string that has name request as the header, quote unquote header. And that name request string will contain the name request, the IP port that the server sent to it, and now its computer name, and a comma separating those two last items. When the server receives this string, name request, it's going to, when the server receives that string, it's going to find that it contains the word or the header name request. So it's going to split it up. It's going to remove name request, and it's going to basically now be a string of just these two items here. This right there. Then this string here, this single entry, is going to be this first and this second item without the comma. So I'm going to use this comma to split these two apart from one another. So single entry index 0 will be the socket that that computer is connected on. And the single entry index 1 will be the computer name that is connected through that socket. Now, as I mentioned before, it was really important that we had to send this from the server to the client, and then the client had to send it back. And the reason we had to do that is because otherwise, the client just, like the server itself, only knows this particular, the server itself, sorry, knows this socket only on its end. And if I were to send a name request without this socket in there, the server would get this computer name back, but it wouldn't know exactly who to connect it to or what to connect it to. So it's important that it gets this along with it. All right, and then once I have my single entry string array, which is the IP, the socket and the computer name, I'm going to put those both into the table that I made, the dictionary table, as here's the key, that's going to be the IP address and the port, and this will be the value, which is the computer name. And then it will add that to the list of items in the IP section, which is right here. All right. So if all goes well, we should be able to actually run this and connect the client, and we should see the computer name at least appear to start off with. So let's try that. And with my luck, it'll crash and won't work, but we will see. All right. So first, here's my IP address. I'm going to start the server, and then here's my client. I'm going to connect. Boom, there we go. All right, and so what I've got here now is instead of an IP address, this is actually the name of my computer right here. that I'm on instead of the IP address populating it. So there we go. We've got step one. Now, unfortunately, what happens is if I try and type something and send it to that particular client, it's not actually going to work. It's going to tell me that I sent it, but it's not going to actually connect. And there's a reason for that, and we'll talk about that right now. So let me stop that. Okay. So far, all of that is working, which is cool. So now we'd have to come up with the next portion of it, which is going to be right here in the send area of the server. So let's explore that right now. Okay, so now I'm at the button send click observable, or I should say method in this case. And what I'd like to do now is make it so that when the server selects the name of the computer, it actually sends the message to that particular computer. So I'm going to go ahead and add a few things to here. And I'm going to keep this mostly as it is. Right now, what's going on here is it checks to see if, obviously if the server's listening. And then it checks to see if the text area that I've typed a message in is null or empty, and that I've selected something, selected a client IP. And if that's the case, if both of those things are basically not true, so it's not empty and I have selected something, then it will send whatever the text is in the text.message to the client that it wants to send to. And then it'll populate the message area with the message that I just sent. So, and then it'll empty out the text message. So what I want to do is I just want to kind of add to this a little bit, taking into account what we've just created or what we just added. So I'm going to start by adding in just a string. We're going to call this IP connection. And that's just going to be a empty string for right now. And then down here in my, after I've checked everything, what I want to actually do first is do a for each loop. And I'm going to do this for each loop with the, let's see, I'm going to look at the table itself. Remember, that's the table that I have created that's going to contain all the computer names. And I'm going to change this to just item, so it's a little bit more easy to read or understandable. And then I'm going to say if the item dot value, oops, so what is going on here? I don't like it when it populates it for me like that, because for some reason the tab thing just does not work the way I want it to. So I'm going to say var item, and that is going to be in the table. There we go. All right. So now, by the way, also, let's look at this. So the item itself in the table is going to be this. It's going to be two strings. It's going to be a string that is, the IP address with the port, or I should say, let me change this. It's going to be the socket. So the IP address and the port get together, and then the other item will be the value, which is going to be the computer name. All right, so essentially this right here, the socket is the key, and the computer name is the value. So what I'm looking for here is if the item that I'm looking at right now as I loop through this, if the value equals the list IP. Go. Now remember, we didn't change the name of this thing. So again, right here, this is list client IP. So it is actually containing, the computer names now, right? So even though we're calling it still list client IP, it contains the computer names. And remember, what I've done here is I've essentially, it's instead of a IP address, it's got a computer name. So I've selected that computer name here. So what I want to do is I want to see if that computer name that I selected, so the selected item, and I'm going to make sure that it's a string, if it is equal to the value of any item in the table. So what I'm doing here is I'm looping through the table, and I'm taking each key value pair, putting it into an item. I'm going to look at the value portion of that item. If that value matches the selected item from the list that I have on the right-hand side of my server form, then I'm going to take the key of that item, and I'm going to store it into this IP connection string. So remember, I want the key, not the value. Right? The value is what the name of the computer is. And right here, my selected item should be the name of the computer. So I want to see if my selected name of the computer actually exists in the table, which it should. There's no reason for it to not. But I'm going to find that value in the table, and then whatever that value is for that like key value pair, I'm going to take its key and set it as my IP connection. And then I'll just be able to, in this case down here, instead of sending to the list client IP.selected item, I'm going to send it to the IP connection. And that's it. And that's going to send my text message. And everything else can basically remain the same. So the end. And that should be it. That should be enough to actually allow me to send messages back and forth now from the server to the client. So let's try that out and see. So here's my server, and I'm going to start it up. And here's my client, and I'm going to try and connect it. There we go. So I've got a connection. So the client can send a message. And then from here, oh, boom, there we go. That's it. And so now whatever computers you connect to this server, you should be able to connect right back. Like the client's name should show up right here in the server, and you can click on it or select it and send it a message to your heart's content. And it will send it because it will recognize that this client computer name is connected to a specific IP address that the client is on. Now there's one more thing that we want to explore here, and it's this. If I disconnect the client, its name still appears right here in the server, which is a problem because I can't send it anything because it obviously is not connected anymore. So let's explore that now. Okay, so now here in the server, what we want to do is take one more thing and add it to here. Right now, as it is with the client disconnected, it'll remove the IP address from that list client IP text box, but it doesn't actually remove the name of the computer. So what we need to do is make sure we actually do that as well. That's kind of important. So I'm just going to add a few things here. I'm not going to delete anything. First, I'm going to say IP address with port equals e dot IP port. And so what's going on here is that E is letting me know which client disconnected. So this is going to be the IP port that disconnected. And if you've been following along up to this point, you probably have an idea of what I'm about to do, but I'm going to do it anyways here just for my own edification and for completionists. So there we go. So we're going to say a string, the computer to remove, and that's going to be just an empty string to start off with. And then we'll go ahead and let's get rid of that. And all right, so now we've got our method invoker here. We're going to add a couple things in this case. Let's see. We've got the textinfo.text, and that's going to show that a client was disconnected. So that's cool. Let's see. I'm going to, in right here, again, just like before with the sending of the message. Oh, see this thing. I hate it when it does this. Like just let me do my thing, man. Just let me code how I want to, all right? Come on, man. All right, so for every item in all these extra curly braces too, just like, man. Okay, so for every item in the table, I'm going to loop through it. If, okay, if that item, if the item dot key in this case dot equals IP address with port. Oh my gosh. Can you, like, now it doesn't want to do any of the autocomplete. There we go. All right, so essentially what I've got here is I've got the IP address that has disconnected. So here it is, e.ip port, and that's what I'm storing as this string. So now that's what has disconnected. I'm going to look through the table, one item at a time, and if the item.key that I'm on at this moment in the loop is equal to the IP address that just disconnected, what I'm going to say then is computer to remove equals item dot value. And the reason I want to do this here is because I need to remove the table, or I remove the item in a table. I need to remove that thing from the table in a spot outside of here. So I'm going to say, and I also want to have the computer to remove available to remove as well. So I could just do this right here and just remove it from the table inside this loop, but that doesn't give me the option to remove it from the list either, because it's was a complicated thing, or at least as far as I was able to see. I could be wrong though, so if somebody finds that it actually does work, then that's cool. Post it. I've already figured out something that I did wrong anyways earlier on in the video, and I'm going to explore that in just a second. But anyways, as I was saying, so I've got right here the item key, which is going to be equal to the IP address with port that this one just disconnected. So now I'm going to say that the computer name of that item that's with that key, I'm going to go ahead and store that in here. And then I'm going to say the list items, the list client IP.items.remove. Instead of the IP port or the IP port, which I don't need to remove, I'm going to remove the computer to remove string. Right? And then I'm also going to remove that particular item right there. Now I could put this up here as well, but I think if I remember correctly, there was an error associated with it. I can't remember what it was. But this table.remove IP address with port allows me to remove it. Oh, I don't remember what it was, but yeah. Oh, that's what it was. If you put this here, that's what it is. If you put it here, the for each loop still continues on. The problem is though, it ends up it has less than what it originally thought it had, and then it errors out because the table was modified, it says. And so with the table being modified inside the loop, it ends up with an error. So it's just easier or better to modify the table outside the loop. And so that's what I do here. Okay, so with that, I should be able to see my client appear in the list and then disappear from the list when it disconnects. So I'm going to start up the server. I'm going to connect. There's my computer. It's connected. I'm going to say, hey, what's up? And here we go. What's up? All right. And now if I disconnect this, I should see this disappear. There we go. Perfect. And that's it. And if let me see if I can do this real quick. If I were to add this, let's go to debug and start a new instance. There we go. And let me bring that server back up. And I'm going to say connect to that. Boom. There we go. Connected again. Yep, still works. So that right there, I know it's kind of a long video, long process, but I kind of wanted to touch on why I did this things that I did. And there is how you can add in the name of the computer to the list instead of the IP address. Now, as you can probably figure out, I did this in particular because I just wanted the names. I didn't want IP addresses because I'm building an application that if I have IP addresses in there, the users are just going to lose their minds. They're not going to be able to handle all that information. So just keeping the names in there is the best way to do it. However, you can probably figure out that you can have both the name and the IP address in that list by simply going to the server portion here where it says data received. And instead of just saying list, oops, there it is. Instead of just having the list client IP.items add single entry, you can probably add single entry plus single entry IP address. I'm going to put them in the reverse order right there, but that should also work just fine. There we go. And now again, you'll have to obviously modify some of the other parts of the methods earlier on to make it work. See, as you can see, I've got my computer name and the IP address. Here's the problem though, is if I select this and try and send a message, it's not going to send a message to that because it doesn't recognize what that is. As you can see, I've got an error going on here, and that has to do with this data send section right here. When I'm sending something, it's looking for just the name. It's not looking for, where is it? Yeah, right here. It's looking for just the name, which is the selected item, not the name and the IP address. So you're going to need to do some modification to that to make sure that it's looking for both the name and the IP address in the table. And of course, as you saw, they were kind of strung together. So you might want to do some formatting there, what have you. But this is basically the very beginnings of it. Now, as I mentioned, there was one thing that I discovered that I kind of made a mistake on, and so I'm going to go back to that right now. So as I was doing the connect, where was it? here in the server with the clients connected and disconnected and all that stuff. The client connected thing, I mentioned that, oh, you have to send the IP port back to it, but that's actually not the case. It's not really necessary. And so what I'm going to do is I'm going to modify this to not send all that extra data along with it. I mean, you don't have to do this, but I found that it's actually not something that's super necessary. So in this case, I'm going to say, let's go back to the client here. And in the data received section, I've got a request name, and I don't want it to have all of this anymore, so it doesn't need it. So let me go back to this. I'm going to just say request name. I'm going to say that, no longer necessary. And so in this case, what I've received now is just simply that. That's it. And so I don't actually need, let me get rid of that plus as well. So if the message contains request name, I don't actually need to do any splits here. So I can just go ahead and get rid of this whole section right there. And well, right? So what I've got is what I want to send back is this name request that. So what I'm actually going, or actually I just want to send back the name request and the name itself. So I don't need this either. So what I'm essentially doing is I'm just going to go ahead and say name request. I'm going to say plus. I don't need a comma there. And I'm going to add in the local computer name. So what I have now is this. It gets rid of this whole section right there. And that's it, computer name. There we go. And it's going to send that back. So client address, client IP address with port. And I probably don't need all that stuff. So I'm actually going to refactor this too so it makes a little bit more sense. Hold on, let me rename it. So I'm just going to say client name. That's it. So I've got client name equals the name request with a plus, and that's going to be plus equals the local computer name, which I already have, and then it's just going to send that back. In fact, if I really wanted to, I could just simply send all of that in one and say, let's see, name plus, and then it will be plus, and then local computer name. There we go. And I can just simply do that, and then get rid of all of that stuff right there. And then what I need to do is make sure that my server understands this new format here. So I'm going to go back to the server, and let's see, when it receives this data, now the data that it receives is actually going to be just this. It's going to be just the computer name. So I'm going to, again, do the same stuff. I'm going to split all that, or like split that up into pieces. So it's going to be just a name request and the computer name right here in the message split. If it says name request, I'm going to skip that and continue. So now it's just going to be that, just the computer name. So I don't need to actually split anything here. Instead, what I'm going to do is, let's see, just to keep that same formatting, just because it'll be a lot easier. I'm going to say, let's see, what's the best way to do this? I'm going to say single entry. Let's say single entry is, and then this will be, let's see, keep it like that. It's going to get rid of that. Continue otherwise. Let's see, var, we'll say var client computer name equals item. There we go. So if it equals name request, then do nothing. Otherwise, do that. Client computer name equals item. And then we'll say the single entry equals, we'll say e dot IP port. And then we'll say item. There we go. And let's see what I got going on here. Still in the for each. Yep, that's an issue. Okay, let me explore this for just a second. Hold on. Okay, sorry, I got myself carried away for just a second. I fell into that classic developer trope where, as a junior developer, I simply just make things way more complicated than they actually need to be. And that's not really what I need to do. So I'm just going to say var client computer name equals string.empty right up here. And then here it's going to be client computer name equals item. And this is going to be just simply else. And I'm going to put that right up there. There we go. Okay, so now the computer name is right there in item. Now I don't need this at all. That's not necessary. And for table.add, what I'm actually going to do is just say the e.ip port for the key, and this is going to be client computer name for the value. And that'll be it. Get rid of that. Remove some of those extra lines. And that's it. And then here for the list client IP, um, that of course is going to be like adding in the computer name. I'm going to just say, oops, client computer name. And that should work just fine. And that cleans up that code just a little bit. I'm sure there's a better way to do this whole for each thing going on here. Obviously that's redundant, so maybe I'll just go ahead and remove it. There we go. And we'll just get rid of that. There we go. I like it when I'm trying to teach, but I'm also learning too. That's pretty amazing. All right, and so with that, let's give that a shot and see what it does. With my luck, it'll of course not work right here on camera, but no big deal. We'll figure it out as we go. So we're gonna start that, and we're gonna connect here, and oh, there we go. We've got ourselves a computer name. And does this work? That is the big question. Oh, it looks like it does. Perfect. Yes, it does. That's always good when that happens. Hey, there we go. Awesome. Okay, so I cleaned up that code a little bit, made it a little bit easier to read, and it made it a little bit more concise too. There's no reason to have like a billion different things in there it's if like what's being sent is exactly what I need. So just to recap what I just did there, I removed all that excess stuff where it had the request name and sending the IP port along with it. That was my mistake. I didn't realize that it actually would be able to. Well, I should have. I should have. But there you go. Again, junior developer making those simple mistakes way more complicated than it actually needs to be. But there you go. Hopefully this was a super helpful video for you. I know it was kind of long, so I appreciate you sticking with me and watching the whole thing. If you did, or if you know stopped or skipped ahead or whatever, that's cool. But hopefully this helped you out at least a little bit. I'll post all of this code on my GitHub so that you can access it, and I'll post the link to that GitHub later or down in the description for this video, so you can just go and get the code if you want to instead. But feel free to use this however it is that you need to use it. And also, as I mentioned before, give, what was it? Yeah, give the Fox Learn videos, give them a shout out. Go over to their channel and check out their original video that I followed in order to make these forms. They got a bunch of cool videos about forms and stuff like that and other different C# applications. So check those out if you get a chance, if you're interested in that sort of thing, and give them a like and subscribe, as well as me too. I'll be posting some more of these videos as I complete this project for work and as I do add different things to it. So with that, thanks for watching and thanks for hanging out, and I'll see you in the next video.